சரி, அப்ப நீங்க விட்டுருங்க. எனக்கு கவர்மெண்ட் தெரியாது.
சரி, இப்ப இது எந்த போர்ஷன்ஜி?
Good evening, everyone. Respected dignitaries, esteemed resource persons, our beloved principal sir, dear colleagues and enthusiastic participants. It gives me immense pleasure to share a brief recap of yesterday's session, day 3 of our 6 days online faculty development program on cultivating innovation AI in healthcare, organized by the Department of Artificial Intelligence and Data Science, Mahendra College of Engineering, with the support of AICT Atal Academy. Yesterday, we had two highly insightful sessions on very relevant topics: AI-enabled virtual health assistants and chatbots, and AI for pandemic prediction and response. These sessions highlighted the growing impact of AI in making healthcare more accessible, personalized, and proactive. The first session focused on how virtual health assistants and chatbots are transforming patient care by improving engagement, providing timely health information, and reducing the burden on healthcare professionals. The resource person explained these concepts with clarity and demonstrated practical applications, making the session interactive and easy to follow. The second session gave us an in-depth understanding of how AI plays a critical role in pandemic prediction and response. We learned how data-driven AI models can help forecast outbreaks, monitor disease trends, and assist policymakers in making quick, informed decisions during health emergencies. This topic was extremely relevant and thought provoking, especially in the context of recent global health challenges. Overall, day 3 was a truly enriching experience, and on behalf of the department, I extend my heartfelt thanks to our esteemed resource persons for their valuable insights. I would also like to sincerely thank all our enthusiastic participants for your active involvement, thoughtful questions, and continuous engagement throughout the sessions. Your energy and curiosity truly make this program vibrant and meaningful. Thank you, one and all.
It is a wonderful feeling to welcome you all once again to this exciting journey of learning. Today marks day 4 of our 6-day online faculty development program on cultivating innovation, AI in healthcare, organized by the Department of Artificial Intelligence and Data Science, Mahendra College of Engineering, Salem, with the sponsorship of AICTE Training Learning Atal Academy. This program has been an incredible opportunity for all of us to dive deeper into the fascinating world of AI and its application in healthcare. Over the past 3 days, we have gained valuable knowledge and fresh perspectives, and today we continue on that momentum with yet another set of enriching sessions. On behalf of our department, I extend a warm and hearty welcome to our distinguished resource persons, our beloved principal, respected faculty member, and our enthusiastic participants. Your presence adds immense value and gives us importance about the meeting. To welcome the resource person, now I call upon Dr. R. Rekha ma'am for the I invite our respected Head of Department of Artificial Intelligence and Data Science, Dr. R. Rekha ma'am, to introduce Mr. V. Elumalai sir.
It is my great pleasure to introduce our respected chief guest for today's event, a committed professional in the field of software engineering and a passionate contributor to the IT industry, engineer M. Elumalai. With an academic background that includes a master's degree in technology, MTech, and a bachelor's in computer science and engineering, Mr. Elumalai has built a solid foundation of Java development, networking, and project management system. His learning journey is marked by dedication and a strong focus on practical, real world applications. He has professional experience in software development, particularly in Java and J2W, and has also explored the domain of Android development. During his tenure at Wings Technology in Salem, he contributed meaningfully to various tech projects and gained hands-on expertise in building robust software systems. Apart from his industry work, Engineer Elumalai has a keen interest in mentoring, teamwork, and technical growth, always seeking challenges that drive innovation and learning. His project spans multiple domains, including HR systems, banking and management, and library automation, all built with a focus on efficiency, structure, and intelligent design. Today, we are honored to welcome a professional who brings a blend of technical expertise, project experience, and a passion for learning, someone who can truly inspire our budding engineers. Let's give a warm round of applause to our resource person, Engineer M. Elumalai. Welcome you, sir.
Thank you. Thank you.
Thank you for the thoughtful introduction, ma'am. Now we hand over the section to Mr. V. Elumalai sir.
So what this topic is AI enhancement remote virtual care. The AI enhancement virtual remote and virtual care is AI based topics. Is intelligence machine tasking is a human act like the computer science. This topics is artificial intelligence. See different aspects the humans being machine learning. One of the popular subsets including deep learning and natural language processing and robotics. First of all, introduce the virtual care. Virtual care is a present cover the concept for the telehealth and telemedicines using technologies to deliver healthcare remotely. That points present the often include on overview of the field its applications, benefits and challenges. They may also tell you into specify the technologies, historical context and future trend in virtual cares. Applications of virtual cares. Applications of virtual cares is here. First one, remote monitoring. Second one, teleconsultations. Third one, home health
Sir,
care.
we cannot see your slides, your PPTs, please. PPTs can't be seen if you are showing the PPTs.
Just wait.
Yes, sir, visible now.
Is right now? This applications of a virtual care, remote monitoring and teleconsultations, home healthcare, specification consultation, disease management, disaster responses. First one, remote healthcare monitoring. Remote monitoring, focusing of the technologies monitoring patients' virtual signs and other healthcare data. Next two topics, teleconsultations. It's a real-time videos and audios interfacing between the patients and providers. Home healthcare is home appliance plus when the virtual care can support patients in the home, including medicines, management and education sites. Is using home healthcare medicines. Specification consultations illustrate virtual care can connect patients, especially under-reserved areas. Disease management. Virtual care managing chronic conditions and diabetics and heart disease. This disease affect the patients. Next topic, disaster response. Role of the virtual care providing medical assistance during emergencies. Benefits of virtual cares. Improve the access, emphasizing virtual cares, overcome geographical barrier and expand access healthcare services. So extrovert cost reduction. Discuss how virtual care reduces cost associated with travel, hospitals, visit, and other traditional care methods. Increase the efficiency. Plus highlights the virtual care streamline workflow and improve the provide productivity. Next topic, enhancement, patient engagement. The virtual care empower patients with tools for self-management and participate the care. This challenging of and limitations. Technologies infrared addressing the need reliable internet and intranet operated devices. Cost of the implementations. Discuss the initial investment and required for the technologies and training. Regulatory and license issues highlight the needs for clean guidelines and regulations virtual care practices. Next topic, patients optic and privacy. Emphasizing the importance of the data security and patients' privacy in virtual care and settings. Reassembling reversible models. Discuss the needs for appropriate politicals and supports a substantial virtual care programs. Trends are AI, future trends, artificial intelligence, wearable devices, and integration with electronics healthcare. Next, for personalized medicines. These topics, AI exploring the potential AI in virtual care switches for the diagnosed, triggered and personalized treatments. Wearable devices discussing the role of the wearable technologies in remote monitoring and patients engagement. Integrating with the electronics healthcare records highlight the importance some less integrations virtual care in system with existing healthcare infrastructure. Personalized medicines discussing the potential of healthcare enable more personalized and target healthcare approaches. Futures of AI. Features of AI: ability of flares and logical discussion making, adaptability, efficiency, automations, visibility. First one, abilities of AI. AI system can be improve the performance evaluations by learning from the data and past experience. Experience discussion making. AI system have a large amount of data, so understanding the regression patterns and analyze the and discussion making. Adaptability. AI system adjust the adapt to change the data in efficiency automations. AI efficiency execute repeatedly task and process. Next topic: AI enhancement remote virtual cares. AI, the corporations of advanced telemedicines and technologies helping artificial intelligence transform the remote healthcare in the enhancement of potential care diagnosis and monitoring and overall medicines healthcare treatments. This reviews experiments how AI has transferred virtual healthcare with records, patients engagement and connectivity, real-time monitoring, health status and accuracy of diagnosis. Key applications: AI switches enable diagnosis system, predictivity, analyticals and teleconsultations platform are reviewed their strength, overcoming limitations of the traditional models remote healthcare. These reviews consist of case studies on the applications AI different healthcare domains, which cardiological monitoring and diabetics management, mental health telepathy, plus the demonstration technologies, and also look either regulatory challenging, including bias, AI data privacy and accountabilities that emphasizing necessity of robust regulatory framework in the safeguard guardians potential patient safeties. AI technologies into remote monitoring patients. Next topic is a remote monitoring patients. Through the AI includes various aspects of healthcare delivery that make system more efficiency, accurate, and patients centric in this work. Impact and role of AI explored with a focus on remote monitoring patients. As a result of the research, it was found that AI support architectures inbuilt or remote monitoring patients have a transform, augmented and revolved new possibilities, applications, and benefits in remote healthcare monitoring. Next group of significant AI applications: learning, transformations, remote patients care, identification, analyticals, and discussed change or facing remote monitoring. Patients also discuss address the change required collaborations among the healthcare provider technologies, developer, policy maker, and patients, and ensure success implementations and widespread adoptions of remote patient monitoring. The result research will be allowed information decisions about the need, benefits, and effectiveness of building specifications, AI-based remote monitoring patients, and developing such architectures with necessary applications for the specific medicines organizations. This topics overall remote patient monitoring system. The sensor, the remote monitoring of the patients sensors on monitoring devices. This can be wearable sensor, heart rate, blood pressures, blood oxygen level, temperature, and other biometrics data as well. Video surveillance cameras, IoT, Internet of Things, and connectivity sensors and devices connect to a central platform by the internet, allowing continuously patient data tracking. cloud infrastructure, the data is collected by the sensor or the data send the store and cloud infrastructure their process and analyzing. AI data and analytical and AI algorithm can be continuously analysis of data from wearable sensor and remote monitoring device to track the vital signs, active the levels, sleeping patterns, and other healthcare indicators real times that allowed medical staffs interval immediately abnormal machine learning. Only machine learning can be include the predict the development disease bomb implementation of dangerous continuously secure and data platform. The collect processing of the medicine data require the high securities and protections and patient the data switches completely data protections and requirements. Generally data protections regulations the European Union. Why to learn of AI intelligence? AI is one of the growing technologies and learning AI would help build career field that high in demand, open the opens of various job opportunity and helps stay in intent evaluation technologies in enhancement problem solving skill. Automated process and can be applied various industrial business to healthcare. The applications of AI is a healthcare AI artificial intelligence healthcare is used associated tasks like dangerous disease, personalized treatments on drugs discovery, financials, finance AI is used for fraud detections, trending and stock market analysis the under customer service through the chatbot. Manufacturing and industrials AI optimization productions process improve the quality and identifications machines failure. Agriculture's AI combines the technologies of agriculture's by the analysis soil conditions. Transportation's AI help design automations vehicle. Some other tasking include the traffic management and route optimizations of the map. Customer services, chart and chartbook technologies and virtual associated AI applications of improve the user engagement. Entertainment and medias. Artificial intelligence help in content creations, personalized contents, recommendations, and target the advertising. Safety and secure AI enhancement, the threat detections, and automated secure measures. Job opportunities. Many companies of requirements highly skilled individuals, AI companies integrated and also operations there will be needs individual to implementation some rules of companies by machine learning engineering and then data scientists plus artificial intelligence research scientists, computer vision engineering, NLP engineering plus from the AI production manager, AI marketing facilities. Then artificial intelligence types based on the capability and functionality. Capabilities is a narrow AI, artificial intelligence, general AI plus super AI plus functionalities AI plus reactive machine learning, limited machine memories, theory of minds and self-awareness. AI. Artificial intelligence tools of framework. PyTorch, Skeleton. PyTorch is a open source framework. Is based on Torch libraries and widely used applications. Deep learning that artificial intelligence it provide the flexibility and dynamic computations craft which make a popular choice of developers use for the various task computer visions and NLP. NLP is a natural languages for processing. Skeleton is one of the libraries. Python's programming language it can be simplify the processing, building and developing the machine learning models and algorithm and user friendly interface and comprehensive range of tools, especially data mining and deep learning tasks. Sklearn is a primary is used performance task like classification, recursions, clustering, dimensionally reductions, futures and selections and data pre-processing. Next, TensorFlow is one of the libraries. Is an open source deep learning framework. Development by the Google's is flexibility, scalable data and often used by the developer build the train and test machine learning models. It will document supports well deployment on the various platforms. TensorFlow is a developing machine learning models, images and recognitions, image recognition and recognitions and writing recognitions, object detections, semantic analysis and machine learning translations. Is a TensorFlow. CARS is a open source high level natural neural network. API is a top of the TensorFlow library and other frameworks. It easy learn and it is friendly. Usually you built-in train and test deep learning models. Is Microsoft Cognition Tools open source deep learning framework developed Microsoft designed to deep neural network and offer a wide range of features and capability and supports multiple neural network type of the including feed for or recurrent network, machine learning model predictions models and also create deep neural network and self-driving cars. It's a long chain. Long chain is one of the framework large language of models. Applications integrate with various tools of OpenAI and using face transformation and used to many applications like the chatbot, documentation, summarization, integrations with the API. Long chain is allowed the developers to child together task the like data retrieval processing and long chain is called sequentially manner. Artificial intelligence applications, healthcare is a AI is used to simplify the life patients and doctors and hospitals managements by perform tasks that were once done manually by the human but less time and cost. It is used to a number of tasks including the drugs discovery, finding the new links between the genetic codes, the surgery assistants, robots, automations, administrative tasks, and providing personality treatments. Next one, financials of AI. AI is a enabled financial service organizations better understand the market, customer analysis, and learn digital journeys, and it helps in the insight of performance measurements, predictions, and forecasting real-time calculations, customer servicing, and intelligence of data retrieval. Next, applications of AI. Automatics or first one automatics, second one e-commerce, third one agriculture. Automatics AI in automatic industry is used to the streamline operations and improve the overall vehicles performance. Some applications of AI in this industrial range of automations, vehicle and advanced safety systems. E-commerce of AI is quite impactful. Various tasks of personalized productions, recommendations of chatbot and virtual assistants, fraud detections and prevents inventory management and dynamic pricing. Agriculture AI AI allowed system make weather predictions, monitoring agriculture sustainability and access farm identification disease, pets using data, temperatures, precision, and wind speeds and sun radiations. Next topic, artificial intelligence, ethics and bias. Algorithm, artificial intelligence ethics bias, algorithm bias and sample bias, prejudice bias, measurements bias, executions bias, selections bias. First one, algorithm bias. Algorithm bias is a system itself factually affect the outcome the algorithm as well as sample biases, data sets in pick up irrelevant data and accurate errors and reflect the result. Free justice bias is a free justice sample bias and prejudice bias use the data influence in social bias like the discrimination. Measurements bias. This bias is when data is incorporated, collect the measurements and integrated. Execution bias is a important data points and left out of a data sets and because human negotiations and good integrations data's knowledge certification or by mistakes. Selection bias is a data data is used to train algorithm does not reflect the real world distributions. Second one, artificial intelligence ethics bias. Privacy, first one privacy and transparency. Third one accountability. Fourth one human dependency, social impacts. First one privacy. Privacy. We feeds of machines with the personal data, details and people's to help the think and act the human, but we details secure the data. Data privacy is one of the crucial concern development on the use AI artificial intelligence. Transparency in the using in the artificial intelligence ethics to the practice making a artificial intelligence system operations understanding the understandable data. You use the disclosure, accountability, the clear data accountability important, especially while the operations critical areas like the healthcare and law enforcements allow the learn who responsibility is outcomes of AI system. Human dependency, artificial intelligence system is a outcome the some human previously used to perform the especially task with the data never take the previously accountability task discussion decision making should be denied. Social impacts, use the AI artificial intelligence to overcome the social interactions and the power dynamic must be carefully consistently positive outcomes. The artificial intelligence um, ethics challenges, the threat privacies and threat human dignity, threat and safeties. AI programs that the recognition speech and understanding natural languages is the theoretical capability of understanding each conversions, each each conversions on email and data telephones, and which leads a society of where people constantly monitoring threat and human diagnostics. AI system have already started replacing the human being. Few industrials, it should not replace the people's sector where the holding the diagnostic positions and such as nursing, surgeon, and judge policies offer, that is etc. Threat and safety. The self-improve the artificial intelligence system can be become the so might compare the human that difficulties to stop achievements goals which may be learned on independent constitutions. Artificial intelligence is a the paper present on the effect of decision making, automations, weapons, leak of transparency, dependency of technologies. This present of the paper present of analysis of research and innovations of self-driving cars. Uh, Self-driving cars, human intents trust decisions made by the machines that make clear data and driving decisions, which simultaneously lead similar solutions, decision making patterns, and auto adjustments. Automations of weapons. There are weapons are capable of selecting a target without human inventions. There rise of ethical concerns about the accountability and the intent of constitutions, lack of transparency, the artificial intelligence algorithm and models of complex are not easily understandable in how they operate and determine the decisions of learning to accountability of issues. Dependency of technologies, the every trend AI technologies for every task creating the concerns about the loss of creativity, decision making, problem solving, and thinking skill. Critical thinking skill. The scope of studies of the paper presents the artificial intelligence research areas. First one, neural network. Second one, evaluation computations, fuzzy logic, cognitive computations, swarm intelligence, machine learning, natural languages processing, computer visions, computer visions, and robotics and expert the system. First one, neural network. A neural network is a first one, neural network. Neural network is a computations model inspiration by the biological neural network of the human brains and designed to process and analyze of data. It consists of interconnections nodes. Artificial neurals arrangements and layers which work together to learn data, make and predictions. Classification neural network are particularly effectively handling complex or nonlinear relationship in data, making them suitable tasking, image recognitions, and NLP, the natural language of processing, and more. And, natural neural network key points. Artificial neurons in layers and connectivities and layout learning and activations functions and in activations. Artificial neurons, thus basic processing unit of neural network analog to biological neurons. Each neutrons receives input the performance calculations on produces layer. Neurons or organization into the layer input the layer, one of the more hidden layer, and on the output layer. Second one, evaluations of computations. Second one, evaluation of computations. The evaluations of calculations dependency heavily on being evaluated on the specification context. Generally valuation method involved assembling fair and market values and association calculation financials radios using discounts and PPE and discount cash flow and approach the next one for fuzzy logic. The fuzzy logic is a form of multiple value logic that handling uncertainty ambiguity allowed the green and truth rather than fixed binary true or false values. Introduce the it is used by the fuzzy sets which boundaries of define the membership functions, whether elements of can logic practical members. Fuzzy logic find the applications various of field from consumer productions like the uh, industrial process control decision support system, enabling more flexible uh, traditional system. Next one, connecting computing. Next topic, cognitive computing. Cognitive computing is referred to the uh, computer system design the simulations human through the process, enable them learn reasons, understand the language in near simulation humans. The system AI, machine learnings and natural languages of processing analysis of a large amount of data and identifications of pattern and make predictions, essentially cognitions of computing AI creation, AI computing machine learnings and solve the problems when the human face the benefits of processing amount of information. First one, computing key points, human cognitions, and artificial intelligence, machine learning foundations. So, third one, driving inside is and natural languages. The machine learning. Machine learning is a artificial intelligence enable the system to solve, to learn data, improve the performance over time without being expertly programmed by analyzing large data using AI algorithm. Plus, machine learning method identifications of patterns, making predictor and decisions become more accurate, increase the data exposure, common applications in product recommendations of stock market predictions, the medical images analyzing and self-driving cars. Is machine learning is what data inputs, receiving the large amount of data, algorithm training is used to find the patterns inside the within the data, model creations. The result in this process is machine learning models is the trained program. Continuously programs improve the as model is expose more than data's performance improve the allowing the to make better predictions and decisions. Next topic, virtual NLP. What is the NLP? Natural language of processing. Natural language of processing is referred to the AI method communicating with on intelligent system using a natural languages such as English processing, natural languages requirement. You want intelligence system like robot performance aspect. Your instructions when you want here a decision from the dialogue based clinical expert system studies, etc. The field of natural languages processing, making computers performance is useful. Natural languages human faced output speech and writing text that the NLP field artificial intelligence focus on enabling computers to understanding interpreted generate the human language. It allowed the machine learning process both text and speech enabled tasks like the languages translations, sentimental analysis and virtual associations. The what is the NLP? Understanding the human languages and generating human languages bridge the tab. First one, understanding human languages, natural languages processing to analyze the structure, meaning, and context human languages and whether spoken written. Generating human languages and natural languages processing gather the human like text and speech and chatbot on other or voice assistancy. The key points of NLP: natural languages of understanding, natural languages of generatings and machine learnings. The natural languages of understandings focus on enabling computers or to understanding the meaningful of text speech. Natural languages of generatings focus of enabling computers to generate the human quality text or speech. Machine learning natural languages of processing, reliable on machine learning techniques and trained models, large data sets, language data enabling them learn patterns and rules of languages. Natural languages of processing on applications. First one, virtual associated. The second one, a search engine. Third one, translation softwares. Fourth one, sentimental analysis. Fourth one, spam filters and chatbot technologies. First one, virtual associated. Sriya, Alex, Google's assistant UC, natural languages processing, understand the respond to user request. Next one, key points of 10 natural languages processing. Natural languages of processing, phonologicals, morphologicals, morphonic syntax, semantics, programming, discover workloads. NLP is a search engine. NLP is based search engines help understanding the user queries and delivery relevant result. Translation, this is NLP is a translation software, power automatics translation between the different languages. Sentimental analysis, NLP analyze the text and determine the emotional tone or sentimental expresses. Spam filters here, identifications of filter and unwanted spam emails. Chatbot is here, engine conversions you use the provide the support informations. The phonological is the studies organizations of sound and systematically. Morphological studies of consist of words and primitive meaningful units. Morphonic is primitive units and meaning languages. Syntax it is referred to arrange the word make a sentence also the involved determine the structure of the role sentence on and phases. Semantics the concerns with the meaningful word concern the combine the word to the meaningful sentence. The programmatics it is with deal with using understanding these sentence different situations and in the interpretations of these sentence and affects world knowledge, including the general knowledges of about the world. The technicals of NLP. The NLP is a field of combines computer science and artificial intelligence and language studies. Languages studies it helps the computers understanding the process and grade the human language with that make the sense the useful with growing the amount of data, text and social media social media website and another source of NLP natural languages programming become key points tools gain the insight the automated task and analyze text translation languages. The technicals of NLP methods of algorithm is used to process analyze and understanding human languages and data and some common NLP techniques. The NLP techniques is used to compare the array of techniques aimed at enabling computers processing understand the human language. Then that can be categories of several boards area each addressing different aspects languages processing NLP techniques. First one NLP first one processing and pre-processing. Second one syntax and parsing. First one text pre-processing, tokenizing and stream limitations and stop removal and text normalization. First tokenization dividing the text to smaller unit and switch words sentence. Streaming and reducing the words and root of form. Stop word removal, removing the common words. Third, the NLP is a tokenization and part of speech and tagging, named entities, recognitions, and sentimental analysis. Tokenization is a technique NLP involved with the splitting the sentence or smaller units now tokens. Part of speech tagging. This is a technique NLP involved with the process of identification and labeling words sentence space in the part of speech noun verb adjective name entities recognitions. This technique NLP is used to identifications name entities that such as people, organization, location, and data set more than sentimental analysis. This technique NLP determines the sentimental analysis to express the pieces of text. Thank you. Thank you to all.
நான் போட்டுக்கிட்டேன் நீயும் போடு.
Sir, we have received some questions in the chat bot. May I request you to answer them?
Madam? Madam, அதாவது இருக்கு.
Sir, I repeat, we have received some questions in the from the participants in the chat box. May I request you to answer them quickly?
Hello, sir. Hello, sir. Hello, sir. Hello.
Hello.
Hello, sir.
Tell me, ma'am.
In what way AI used in expert system, sir?
Okay, just wait. Ma'am. Yeah, it's what way AI used, what way AI used the expert system. The expert system is in AI. Expert system is a crucially subset of artificial intelligence. Similar the decision making ability of human expert. The system's knowledge based the field domain specific the informations and rules. Interpreters solve the complexity of the problems. The expert system importance the preserving expertise and improving the decisions and saving the timing and many money and also accessibilities. Accessibility. The expertise system is closely and artificial intelligence based the domain specification, informations and rules and to solve the complex problem. For example, medicals and expert system can analysis of the patient's symptoms and suggest possible diagnose the treatment and simplicity. Financial and expert system can be evaluate the market trend and recommendations of investment strategies.
Okay, thank you, sir.
Okay, thank you.
Give the example for natural language processing, sir.
Yes, 1 second. Yes, one second.
Okay, sir.
NLP give you examples. The NLP is the NLP is a smart assistance of Switch Sri and Google's assistants. Sri on Google's assistant, which is the understand the your voice and comments and processing and the underlying meaningful and provide the relevant spoken textual responsibles and other everyday examples, including the spam filter and productivity text and translation app. The speech to text, how it is the work the NLP is the speech to work plus on the natural language understanding plus on the responsible and generating on the otherwise the world NLP email and spam filters and search engines sort of accommodations of and suggest translations of chatbot technology, sentimental analysis and auto correlations and text predictions. That's all, ma'am.
Okay, thank you, sir. Okay, thank you, sir. I got it.
Oh, okay, thank you.
Sir, we have received some questions from participants in the chat. May I request you to answer them?
Okay, thank you. Tell me.
Sir, the questions are in the chat box. Kindly check them, sir.
Questions?
Questions are in the chat box, sir. Kindly answer them.
Okay. Chatbot.
Yeah, sir.
Just 1 second, ma'am.
Sure, sir.
Ma'am, chatbot is a chatbot is conversational model. This sort of is artificial intelligence research. A chatbot can be found the variety of settings and including the customer services and applications on online help task. The spot of often powered by retrieval based the models and which output predefined responsible and questions and studying the forms in a highly restriction domains like a company's IT help task. Thus models may be sufficiency. However, they are not robust enough for the more than general use case teaching the machine learning and to carry off meaningful conversions on human multiple domains in research questions that is form solved, that is the form that is the chatbot technologies is solved. Okay, ma'am.
Sir, we have received few more questions from the participant in this chat. I'll read it out for you. Can you answer them, sir?
No, yeah, tell me.
What role does AI play in mental health or behavioral health in monitoring virtually?
1 second, ma'am. Madam, AI is significantly impacting mental and behaviors and health bar monitorings by enhancement early detections, providing personalized the inventories and improving the access care. AI powered tools analyze of various data points, including the speech patterns and text facial expressions and even wearable sensors, data and identifications suitable changing that may indicate the on-site and program site mental health consists of allow the timing inventory potential prevents the escalations of problems. Okay, ma'am. The personalized of treatments inventory, AI power chatbot, virtual assistants, and predicting models, machine matching the patients and reducing the stigma. Next, ma'am. Are you clear, ma'am?
Okay, so what is the difference between virtual learning and remote learning?
Sorry, ma'am. What is?
So what is the difference between virtual learning and remote learning?
1 minute, ma'am. First of all, virtual learning is a focus on technologies. Uh, Virtual learning is a interactive technologies and like simulations and virtual reality and creations and impressing the experience in the remote learning. Remote learning is a border of terms and focus in insertion that task the place the outside the traditional classroom and often with less interactions. Okay, ma'am. Hello. Are you clear, ma'am?
Yes, sir. Thank you, sir. As we continue, we will now play a short video that focuses on AI-enhanced remote virtual care, showcasing its impact on modern healthcare systems.
Artificial intelligence is everywhere. It touches every aspect of our lives. But what is AI? AI systems are computer programs that are inspired by the way humans solve problems. Most of these systems learn from data and either make predictions or generate new information. Some AI systems can also adapt to new information and continually improve over time, making them powerful tools for solving complex problems. History of AI. The journey of AI began with Alan Turing's pioneering work on computing machinery. In 1956, the Dartmouth Conference coined the term artificial intelligence. They proposed that if every aspect of learning and intelligence can be precisely defined, then a machine could be designed to simulate these. In 1997, IBM's Deep Blue was able to show AI's potential for outperforming human intelligence in complex tasks through defeating the world chess champion Garry Kasparov. However, this program still heavily relied on human knowledge. 20 years later, DeepMind's AlphaZero further advanced AI through mastering chess, shogi, and Go, and even developed new game strategies by teaching itself to play. Types of AI. There are various types of AI, including machine learning models and the more advanced subset known as deep learning models. Machine learning involves simpler algorithms that enable computers to learn and predict from data without explicit rule-based programming. For example, categorizing a patient's diagnosis based on symptoms and test results. Deep learning, inspired by the human brain structure, utilizes multi-layered neural networks. This can give the model exceptional accuracy and performance in complex tasks previously considered impossible. Predictive deep learning models make predictions based on existing data. For example, when you're trying to unlock your phone with your face. Generative deep learning models generate new data that is similar to existing data. For example, when generating a picture of a person that does not exist. Based on the type of data that these models can process, we categorize them into image recognition, natural language processing, audio processing, recommendation systems, forecasting, and many others. AI in healthcare. AI has the potential to revolutionize healthcare through early disease detection, enhancing treatment precision, and optimizing back-office operations. Natural language processing models can help busy practitioners to summarize texts and support diagnoses from notes. Image recognition models have the potential to enable early detection of cancer and other diseases through automated imaging data analysis, allowing for timely interventions. AI-driven predictive analytics applications are used to assess disease likelihood, improving treatment outcomes. Additionally, AI can reduce drug discovery costs by predicting new chemical compounds and their likely effect on the body. In surgery, AI-powered robotics can increase precision and efficiency in complex procedures. Understanding the challenges of AI. As healthcare leaders, it's important to understand the potential of AI and how it can be implemented to boost efficiency, reduce backlogs, streamline operations, and improve outcomes for patients. It can enable us to drive forward innovation and transform how we provide healthcare. However, this is set against a backdrop of complexities and a fragmented NHS infrastructure, which can make adoption of AI a challenge. Do we fully understand the underlying problems we aim to solve with AI? Have we developed a robust data quality framework to guide its use? How do we achieve post-market surveillance to avoid unintended consequences and hallucinations? And how do we upskill and empower workforce to safely implement and use these technologies? To solve these challenges, a defined strategy is required with clear implementation plans and inclusive engagement with all those involved, from patients to system leaders. Together, we can enable a world-leading health system like the NHS to develop and adopt AI technologies equitably and safely to create a healthier future for all.
Before Sir continues again, we kindly request all participants to fill out the feedback form for this session. Your responses are very important to us as they will help us improve and make future programs even better. I repeat, before Sir continues the session, we kindly request all the participants to fill out the feedback form for this session. Your responses are very important to us and they will help us improve and make future programs even more better.
Imagine in a virtual area, it's a rural area, a 70-year-old man is living. His medical history says he has a cardiac arrest, but he can't move to a hospital within a reachable time. Now, instead of he wears a smartwatch. That watch records his rhythm of heartbeat. That indicates him what is heart moment, when it will be critical or it will be normal. So this is not a science fiction. It is an IoT device with an AI combined. It can help him anyways. Before we conclude, let's pause and reflect on the keywords we have learned today. AI in remote patients monitoring keeps and patients of a safe at home. AI chatbots and virtual assistants are available 24/7 for basic guidance. It's not a complete doctor-like session, but it's a guidance which supports us to home medic. AI supports teleconsultations by summarizing and predicting and even translations. AI in diagnostics and imaging increases accuracy and accessibility. AI for mental health and medication adults provides continuous care. So, in essence, AI doesn't replace healthcare. It extends healthcare beyond hospitals into homes and communities. Ask which of these applications do you think would make biggest difference in your city or workplace or in a rural area, urban? Deep reflections. Every day, great technology comes with great responsibility. Let's revisit the challenges. Data privacy. How we save your health data in the cloud? Imagine we are uploading the data with cloud, which is related to our mental and the physical health. It remains daily. It's not an assistant, it's AI. Bias in AI models. Can we trust AI equally for everyone? No. The answer is no. We can't trust. But we may just align with the AI, then go on. Legal issues. If AI makes a mistake, who is accountable? Can you have the answer? No. No one can have the answer. Digital divide. What about the patients with no internet access? These are the like disadvantages of AI. Okay. Mini case of the reflection. Imagine an AI tool that correctly diagnoses heart disease in 90% of urban patients, but only 60% in rural patients due to poor training data. Should hospitals deploy it or wait until it's perfect, right? Closing notes. These challenges remind us that technology is not only an ethical and fair people designing and employing it. Future vision opportunities, right? Now, let's look at the road ahead. AI in virtual care is moving towards 5G and IoT real-time monitoring, digital twins, predictive healthcare, AI and robotics, multilingual AI assistants, right? Nowadays, everyone have ChatGPT in their phone. ChatGPT can assist with your mental and physical health, your cardiacs, and many and so. Interactive audience engagement. You have two options with that, quick poll and mini role play. The quick poll rules who had the trust AI more than a human or doctor basic diagnosis. Who believes AI should only use a support tool, never independently. Then mini role. The mini role is the person who plays as a patient and one plays as a doctor. One plays an AI assistant. So, how an AI might support teleconsultations, AI suggests, doctor confirms, patient feels assured. That we will create an interactive and memorable ending. The final inspiration is that to conclude, let's remember AI is not to replace doctors. It is here to make healthcare smarter, faster, and inclusion. But technology alone is not enough. We must build systems that are ethical, fair, and access to all. The future of healthcare is not about only machines. It about human also. It's about machine plus human working together for healthier life for us. The hospital of the future is not a building. It's your home, your wearables, your phone, and all connected devices through your AI. Final thought of the session is AI will not replace doctor, but doctor who use AI will replace who don't use the AI. Would you like to turn this with a session along with that? It is a session that how can an AI enhance with the remote and virtual care? So, what is the benefit of AI in virtual care? We can ask that. Which are all the benefits we use in AI that can help us? Accessibility. Patients can be anywhere in rural areas and urban areas with the different types of physical deficient in their body. Like accessibility helps in patient remote or rural areas can easily accessible, not curable, but accessible. AI is a perfect assistant to assist you, but not to treat you. Remember that. India's e-Sanjeevani telemedicine platform has already provided over 100 million consultations using only AI, which is effective for many people who are in urban area. Cost effectiveness prevents costly hospitalizations. For a minor surgery or any other minor demands in your body, it can be more cost, which is cannot be affordable for many peoples who lived in urban areas. The cost effectiveness in AI will be very perfect to who can't afford their medical bills. So Mike Kinsey plus AI estimate here, telehealth could save 250 billion annually in US healthcare. US healthcare grew that's an 250 billion annual income, which is retrieved instead of using doctors on medical bills. Continuity of care. There is no person will be assist you in at your home. You may lonely or any other people without the medication knowledge. AI can assist you. Like chronic disease patients like diabetes or asthmatic, don't wait for 6 months. AI tracks them daily, which can be very useful for them. Imagine a diabetic patient who has to poke that in a finger and monitor every day. He can't afford medical bills, but AI can replace that. That is the effectiveness which AI can give them instead of doctors or medical assistants. Efficiency of doctors. AI reduces admin burden, but doctor spends more time with on patients. Not every AI can personalize you and analyze the daily effect causes on you, but AI reduces the admin burden. Personalization of AI trades treatments, diets, and exercise plans to individuals. Individual people have many different concerns with their bodies. Someone may obesity, someone may skinny. Not every person know about every people, but AI suggests you a perfect medication plan and assist you for different kind of people at different times. Mini story of Namajan feedback. Do you want to hear that thing? Ravi, a 50-year-old diabetic patient living alone. One night, his AI-enabled glucose monitor detects a sudden drop in his glucose. It's an emergency situation, right? But he's alone. What can he do? Instead of a person or a medical assisting, and all thing goes to Ravi, his family, and doctor. None of them provide us. AI sends a message and an emergency situation causes to Ravi, preventing what could have been in a life-threatening emergency. This is the power of AI action. Instead of everyone, AI sends the message to his relations or any nearable medication center. Challenges may be caused in AI, like data privacy and security. Health data is highly sensitive. Breaches can have severe consequences. Like example, in 2021, the telehealth app breached exposed 150,000 patients records, which is a data threatening, right? 150,000 patients records has been leaked on online, which can be accessed to anyone. That's the risk in AI. AI bias and fairness. If trained mostly on Western data sets, AI may misdiagnose people from other regions. Like skincare cancer worked on poorly on dark skin tones. But AI can morely compare and says the wrong data sometime, but not the most of them, but sometimes. Okay. It's the conclusion of our content that an AI enhanced remote and virtual care. These all are the AI content which can be caused in future or nowadays. Thank you for your cooperation, gentlemen. Thank you.
Before we proceed, we kindly request all participants to fill out the feedback form for the session. Your responses are very important to us as they help us improve and make future programs even more better. It's my privilege and honor to express our heartfelt thanks on behalf of Mahindra College of Engineering to Mr. V. Elumalai sir for joining us and sharing your deep insights. Sir, your presentation was not only informative but also thought-provoking. You have explained complex concepts in very clear and practical way, making the session truly engaging for all of us. The real world applications and examples you have shared have given us a better understanding on how AI is revolutionizing healthcare and how these technologies can make real difference in patient care. Your time, effort, and expertise are truly appreciated, and we are extremely grateful that you could spare time for your busy to be with us today. Thank you so much, sir, for making this session impactful and enriching. Now, moving on to our second session of the day, it is my pleasure to invite Mrs. Indumati ma'am to introduce our distinguished resource person, Dr. M. Alagiri sir.
Good evening, everyone. It is with immense pleasure and honor that I stand before you today to welcome a distinguished academician, accomplished researcher, and passionate educator, Dr. M. Alagiri. Our esteemed chief guest for this event, Dr. Alagiri is currently serving as an associate professor in the Department of Computer Science and Engineering at SRM University, Ramapuram campus, where he has been shaping your minds since 2017. His academic journey is both inspiring and commendable. He holds a PhD in computer science and ME in Computer Science and Engineering from Anna University, and a BTech in Information Technology, all backed up deep dedication and consistent excellence. Additionally, he has also completed an MBA, reflecting his well-rounded perspective in both technical and managerial domains. Dr. Alagiri's contributions to the field of computer science are extraordinary. With 25 plus research papers published in Scopus Index journals, multiple conference presentations, and several book chapters, he has explored diverse areas like machine learning, cybersecurity, IoT, deep learning, and medical data analysis. Beyond research, he has also filed multiple patents on cutting-edge innovations such as AI-based intuition detection systems, IoT health tracking, water purification using nanotech, and cybersecurity for smart industries. He is also a proud member of several professional bodies including ISTE, IAENG, IRED, CSTA, and more, a true symbol of his commitment to lifelong learning and contribution to the tech community. Today, we are honored to have him among us to share his knowledge, insights, and journey. His presence is sure to inspire all our students, researchers, and faculty members. Please join me in extending a warm welcome to our chief guest, Dr. M. Alagiri, a true scholar, visionary, and educator. Welcome you, sir.
Thank you for the thoughtful introduction, ma'am. Now we hand over the session to Dr. M. Alagiri sir.
Very good evening to all the participants in the FTP. Whether my voice is audible to everyone?
Yes, sir. Now
Yes, sir, audible.
Okay, thank you. Thank you. Can I start the session?
Yes, sir.
Yes, sir.
Whether the PPT is visible to everyone?
Yes, sir. Visible, sir.
Okay, thank you. Very good evening to one and all present in this particular FTP organized by Mahindra College of Engineering and Technology. So I'm Dr. Alagiri, working as an associate professor in the Department of Computer Science and Engineering at SRM Science and Technology, Ramapuram, Chennai. So today I'm going to deliver the session about the machine learning for the disease prediction and the risk what we have, how we are going to handle this particular risk. Okay, so we are going to predict two things. One, it is the disease prediction, and the second one is your risk prediction. So when you name the terminology named as prediction, it is somewhat like your assumption, okay, by using different strategies, okay, how to prove or how to show it with different algorithms what we use, okay, in the machine learning. Okay, first and foremost, I should say about what is meant by machine learning. Okay, so if I'm taking the case of this particular machine learning, so it is a branch of the artificial intelligence. okay, which is used for predicting the results based upon the incoming data or the gathering data. So what is mean is this particular incoming data or the gathering data? So in some cases, what we'll be doing of means we'll be collecting the particular information and we'll be storing and we'll be keeping off. So this particular thing, I cannot do it in your large volume. Okay. So what I will be doing of means we'll be going with the concept of your data sharing. So I may go and collect a few datas. Okay. For example, let me take, I'll be collecting some 50 datas and you may collect this, the same similar field, next 50 data. So like this, we can collect the data and we can group based upon the particular futures what we have. So this method we'll be using here in the case of the incoming data. Okay. The next thing we'll be going in the case of the algorithms. Okay, we'll be having a n number of algorithms. First, let me say only two different categories what we have. Okay, we'll be saying it as your supervised and unsupervised. Okay, so the next thing it is we are going to train our machines. Machine is nothing but here we'll be saying it as your what means the computers. Okay, so we'll be slowly training the particular machine. Okay, so based upon this particular training, what we'll be doing of means we'll be trying to test particular inputs what we have in our hand. So this is a basic work of your machine learning. So if you are going off, as I said earlier, we'll be taking the particular input data. So this particular input data, since here we are speaking about your what means your disease prediction. Okay, so here what we'll be taking off means maximum will be going in the case of your the data set of humans. So when you work with the particular data set of your humans, we have to go with the consideration which we'll be saying as your ethical considerations. Okay, so what is meant by this particular ethical consideration? I'll be speaking in the second half of this particular thing. Okay, so for example, if you want to know what is this particular input data, I'll be saying in the field of as a small example, in the networking or in the field of the agriculture. Okay, I hope we use internet daily. Okay, I hope here in this particular FTP, we have lots of people working in the different organizations. Okay, so what happens here is you will be working in your computers, which will be saying as your machines. So in your computer, I hope we'll be having here a device named as firewall. Okay, in your organization. So what is the work of this particular firewall? So the work of this particular firewall is to collect the particular request what you're sending off. Okay, for example, one end you may keep it as a what means your client. The other end will be keeping it as a what means your server or the service which provides the like your internet. For example, in the particular firewall, if we write a particular rule, okay, catch, okay, catch, we should not say it as a catch, okay, identify the IP addresses and the username whose request is coming to download more than, for example, 100 MB. Okay, so like that, let us put a particular rule. Okay, so what happens it is, so based upon the rule, what you're written and kept, okay, we'll be collecting the particular information. What are the information that it will be collected? Okay, so I'll say very few particular features or the parameters what we know. What is the IP address of the machine from where the request has been came to download or to fetch the information of more than 100 MB? This is a point number one. At what time this particular request is coming off? How many times this particular request is coming off? Okay, we'll be saying it as a sweep in, sweep out. So like this, we'll be saying as your futures. Okay, so like this, we'll be collecting the particular information. Okay, so the next thing, what we are going to analyze in the particular, in the case of your data
Sir, can you
analysis.
please be a little more louder, sir?
You want a little bit louder? Is it not audible? Is it audible now?
Yes, sir.
Okay, fine. So
Thank you, sir.
here, what we are going to analyze in this particular area means we should have like your threat or a vulnerability if a particular user downloads more amount of data, then the other users could not use the particular resources. So like this. So what we'll be doing of, so based upon the particular analysis, we have identified the particular IP address. So based upon this particular IP address, what we'll be doing of means we'll be restricting. Okay, we are not going to restrict all the persons. We are going to restrict only the particular user. We are going to restrict only the particular users who's very frequently downloading more than 100 MB or 200 MB. So like this, we are going to have a small analysis. So the next thing will be finding the particular patterns. Okay, and just a minute, I'll go with the slideshow. Is it clear? Is the slide is clear? Okay, so we'll be finding the particular patterns, why this particular thing is occurring very frequently. So like this, we'll be going off. And next, it is your predictions. So for this particular predictions, we require the particular different types of algorithm. So let me go with the concept of a very simple classification, like your what means your decision, random forest decision tree. So like this, we'll be going with the concept of your simple uh, what to say classification. Based upon the particular classification, we'll be predicting and we'll be coming to your conclusion. So we'll be going for the further improving steps. Okay, so see here, when you go with the concept of your conventional programming method versus your machine learning method. So what is mean by this particular conventional programming method? So if you go in the case of your what means conventional in the sense, I hope you will be writing your program codes in the C, C++, Java, and all those programming coding languages we'll be saying. So in this, what happens it is we'll be manually creating the particular program. Okay, and the user data also will be giving either in the case of your what means dynamic or static one. So based upon the particular input what you are given, this particular conventional program will be working off and it produces your results. Here, what happens it is the input what it'll be giving, it'll be very less in number in the case of your testing. So what is mean by this particular machine learning? So in the case of the particular machine learning, what happens means we'll be trying to pass the particular input data. Okay, and we'll be having the particular algorithms. Based upon this particular algorithms, we'll be feeding the particular what means different types of strategies. So based upon the particular different types of strategies, what it will be doing means it will be creating a particular program and it produces a output. Okay, here we should not say it as your exact output. It produces the particular result. Based upon that particular result, okay, we'll be saying that's your confusion matrix. So based upon that, we'll be calculating the accuracy, how accurate the particular results it will be producing of. So here what we'll be doing means we'll be including n number of different types of packages, okay, for working with the different strategies. Okay, so what are the different types of machine learning that is available? So yeah, machine learning is being classified into three different strategies. One we'll be saying it as your supervised, the next we'll be saying it as your unsupervised, and next we'll be saying it as your reinforcement learning. Okay, so if from this only we are going for your deep learning and the other things. Okay, so let us see what is mean by supervised learning. Okay, so here in the case of the supervised learning, what happens it is we'll be having like your what means your teacher. Okay, so what the teacher will be doing? The teacher will be training you people. Okay, training you people by showing the particular object, stating that this is your apple. Okay, this is the orange or this is the fruit. So like this will be training it. So how you will be identifying and how you will be remembering this particular thing means either by marking by the parts, okay, by the parts, shape, structure. Okay, so like this, you will be remembering and you will be keeping off. So this particular thing will be saying it as your labeling the particular thing. For example, we say A for apple. Then for the letter A, what we'll be doing of means we'll be marking this and we'll be keeping it as a what means a apple. Okay, so like this we'll be marking and we'll be keeping off. Okay, so what happens it is when you provide a particular data, I hope in the kindergarten, what we'll be doing, the teachers will be doing of means, when they show the particular object, the small kids, okay, they will be identifying and they'll be saying that this is an apple, okay, this is an orange. So how it has been gone means, I can say one more methodology, the terminology, like a activity-based learning, okay, or by visual representation. So like this, okay. So the student has like a by-hearted or memorized, okay, and they are keeping in the particular hand, in the mind, okay. So like that, it will be going on, okay. So the next thing, if you want a real-time examples here, the case of this particular supervised learning, we'll be saying it as your what means a spam filter. Just now I spoke about what is means a network, firewall, and all those things. And we'll be going in the case of the fraud detection. So we'll be using the classification mechanisms. So like that, it'll be going off. So the here the speech recognition, okay, like voice to text. Okay, suppose we speak hi, hello. I hope in your Google now it has been embedded. So voice to text, the words what I speak, it recognizes, okay, the machine is nothing but your laptop or a computer, it recognizes and it produces the particular equivalent character, okay, or the token. So this particular thing is coming for us, okay. Maximum here, the accuracy level nowadays in the case of your Google is somewhat more higher. The next one, it is your image classification. So image classification plays a major role in the field of this particular medical analysis. Okay, so these are the few real-time examples what we are going to see. Okay, next, what is meant by unsupervised learning? So it is somewhat a small grown-up stage when compared to your supervised learning. So when I said a small, how we are going to handle the particular supervised learning means only one particular object I have shown, that particular object has been labeled, and that particular thing, the small kid, okay, in the kindergarten, what we have, they'll be remembering and they'll be keeping off. Okay, so next, slowly what happens is we are trying to give more number of objects, okay, more number of data. So what happens is, so we are teaching the particular student, this is a apple, this is a orange, this is a banana, this is a pineapple. So like that we are giving off. So when you go on the case of your unsupervised learning, so here the labeling will not be present, okay, the labeling will not be present. I can say it is your mixed data. I can say this is your what means mixed data. I hope you can see here in the images. Okay, so what happened is, if the particular mixed data has been given, okay, how to find the particular object that is present for us, how to find the particular element that is given in the particular input. So what we should see of it, we should see the particular patterns or the behaviors in this particular area. Okay, so based upon this particular pattern and based upon this particular behavior, we are going to classify this particular what to say means the elements or the objects what we have as received as your input. So here we are saying it as your model. Okay, what type of models we can use in this particular area? So we are going to see in the next particular slides. Okay, so here maximum the particular data or the information, it will be present how much in the unsorted manner, like your mixed manner, it will be coming off, okay, according to the reassemblances, okay, and the patterns and the variants, okay, of your training data. So like this, it will be present here. Okay, so what are the real-time examples that you will be having of? So very physical real-time examples, if I want to give means, assume that you're present in your classroom or in your computer laboratory. There, for example, the students are coming off. So what you'll be doing, the students, they'll be in the, for example, boys and the girls will be in the mixed manner. So what you'll be doing of is, based upon the, what to say, the dress code, okay, you will be segregating. Okay, all boys go to the left side, all boys go to the right side, or all boys go to the room 1, all boys go to the room 2. So here the dress code plays your major role, or else some behavioral pattern we can keep it off. Next, we'll be going in the case of your anomaly detection. Okay. If this particular anomaly detection, it will be used where means in the case of your network-based activities. Okay. So if you want to say here means I'll be saying two categories. One, it will be as a what means normal behavior. One more, I'll be saying it as your abnormal behavior. Okay. So I hope 10 normal data will be coming off, or normal data is nothing but your authorized users will be coming off. In between that, intruder also will be entering into the particular network. So we cannot say that all the data which is coming here is continuous. Okay. So the 10 data are continuously a normal data. The 11th data also will be your normal data. We cannot assume and say. Okay. So here in the unsupervised, so that only it has been not labeled. So we have to find each and every data what you receive. And the next we'll be going in the case of your pattern recognition. So this particular pattern recognition is used in the case of your grouping your images or classifying the particular images. Okay. Next, we'll be going in the case of your optical characterization. So here, based upon the handwriting, what we are having. So it recognizes, okay, for here we'll be going in the case of a writing, okay, handwriting, what we have, the OCR images into your, what the same is a digital text images. Okay, so like this, we'll be going in the case of your unsupervised.
இவரு தெரியுமாப்பா அழகிரிய
mechanisms. The next thing it is, we'll be going in the case of your reinforcement method. Okay, so just take the general meaning of this particular reinforcement. Okay, you're trying to force something. You're trying to force something. So how this particular forcing has been done? Okay, that is the question what we want to raise in this particular area as a first one. Okay, so the case of your supervised and unsupervised, what we'll be doing of, we are writing some rule. Based upon the particular rule, we are classifying, okay, whether it's a normal or an abnormal in the case of your network oriented. Okay, in the case of, if I take as objects like your apple and all those, it's based upon the color, based upon the structure, okay, everything it is classifying and it is putting off. So here, few things we cannot classify so easily. Okay, so what we'll be doing of here, we'll be going in the case of a two parameters. What are the two parameters that we will be seeing or will be using in this particular area? Means we'll be going with the action, how it is doing off, and the for the particular action, how it is behaving. Okay, the observation. So like this, it will be going off. So here, what we'll be doing off means we'll be having your input and output particular parts. Okay, so based upon this particular input and output, what we receive, we'll be measuring its particular performance. Okay, so based upon the performance only, here what we'll be doing of means we'll be taking the particular outputs. Okay, so this particular thing, environments, it will be in the case of like your game theory, we'll be saying of. Okay, like game like situations. Okay, it will be going like a trial and error. Okay, so for example, I can give one more example also in this particular area. What is the one more example I want to give here means there are two people standing here. Okay, a coin has been tossed. Okay, you can consider your cricket match. When a particular coin has been tossed, then what happened it is one person will be saying it as a what means a head. Okay, the second person it has been forced him to take it as your tail. Okay, so what happens is only one person is asking. Okay, I'm going to ask about head. When the particular coin has been tossed, okay, it is coming and it is falling down. When it falls down, it is not the laying down properly. Okay, for let's take it as somewhat standing in the 70-degree or 80-degree due to some obstacles that is present here. So what happens here? One person will be claiming that, okay, only head is present. The other will be claiming that it has been not lie down properly. So what happens? We'll be coming to your decision, okay, based upon the particular trial and error, what we'll be having of. So like it will be going in this particular case of your reinforcement learning method. Okay, so the examples here, what we have in the case of this particular reinforcement algorithms, it is self-driving cars, automated robots, okay, natural language processing methods, traffic controls, okay, automated traffic controls, marketing and advertisement, the gaming activities, what we'll be doing of. So these are all the few examples of the reinforcement learning methodologies. Okay, so here we have a small example. Okay, so a day-to-day activity, how we are going to use it. Okay, so here we have lots of what the same is the image that's present here. So if I go in this particular the machine learning applications, what I have, okay, in the day-to-day life means, for example, I'll be going in the case of your automated translation of the particular what to say, voice to text I'll be saying of. Okay, so the traffic prediction, what we say. So this can be monitored in the case of the machine learning. So I hope in few areas it has been implemented. Okay, so the camera they are kept. So by keeping the particular camera, the camera detects the particular number plate of the particular vehicle, which is not following the traffic rules. So automatically the fine has been generated. The next we are going with the concept of what means the search engine results. Okay, online fraud detections. Okay, hope you'll be having the app named as a Truecaller. So in that particular Truecaller, if more than 10 to 20 people mark a particular number as a spam number, so when it, a call comes for few people, it shows in red in color. Okay, spam call. So like that, it will be going off. Okay, even Truecaller also, we should not believe it. Okay, it is also not. Okay, the next will be going in the case of the medical diagnosis. So this is a part which you are going to see in detail, in depth with the example, with a small project, what we people has created. Next, classification of the email, okay, the normal email, the abnormal email, okay, spam filtering. So if we need, we can train your email also, which particular emails to be pushed to your spam. Okay, so like that we can train your nowadays your email, Gmail, what you have. The next one, it is your image recognition. So this particular medical diagnosis and this particular image recognition. So these two things plays your major role today in the field of medical field. Okay, so what the particular machine learning can do? Okay, so this is a question. What it has been. Is it clear, or is the voices clear? Any problems? Okay, hope it's fine. Thank you. Okay, so we'll be having the personal assistants, okay, like Alexa, Google Home, and all those. So by keeping this, we can monitor or control all those things. Okay, let me go for the important thing for the metropolitan cities. Okay, traffic forecasting or traffic predictions. Okay, even day to day, we use this particular thing. Okay, first when we start to move from our college to our home, we'll be seeing the traffic where it shows the red, where it is blue. Okay, so the red says that the particular traffic has been more. Okay, how much time it will be taking for crossing this particular area, and it will be going off. This particular thing plays a major role, I hope, in Chennai and in Bangalore. Okay, and in this particular thing itself nowadays, by keeping the Google map while traveling from your source to destination, I hope in a funny way they started to tag. Okay, here checking is going off. Okay, police is putting fine and all those things also in this they are doing nowadays. The next it is video surveillances. Okay, I hope this plays a major role nowadays. Okay, so everything goes remote. Okay, everything goes in the case of the remote. So here what we'll be doing of means when the unusual people are moving here and there, I hope we can report or can file a case, okay, from the remote area itself. Okay, so this particular thing plays a major role in the case of your video surveillances. And the next thing, in the social media, okay, take down your Facebook or take down your Instagram, whatever you want. So what type of videos that you're liking or you're preferring more? So those type of things will be continuously, it will be coming and it will be showing in your suggestion. Okay. So these are things that is present environments in the case of the social media. Next, let's go in the case of the email spam and how we are going to filter the particular malware. Okay, so here, why we are saying this particular message as your spam? That is a question. Okay, so when you say it as your spam or it is your malware, maximum we will be marking the unwanted things. Okay, unwanted things means which is not relevant for us. Okay, so that particular thing only will be marking it as a what means yes spam. So here what it will be doing of what will be marking, so that will be the next question. So the ads what they send. Okay, so if it comes to my inbox, it is disturbing continuously. So what I'll be doing, I'll be marking 1 or 2 times to push to your spam. So automatically the third time if it comes, it will be moving to the particular what is this spam mailbox. The next thing, what is the malware and what are the problems that we are facing here means the executable codes they'll be sending off. Okay, I hope yeah, thank God. In a Gmail, when you try to download a particular attachment, automatically it is scanning for your virus, whether any virus is present in the particular thing or what. So if anything is present in such a way, it says that, okay, it is what means like your unsupported file, or it contains a suspicious code or a malware thing. So we'll be having the viruses, Trojanos, okay, or different types of executable codes, which will be running n number of types like your loop, okay, which will be occupying your memory. Okay, so like this it will be going off. Then next we'll be saying as a online fraud detections. So like that it will be going. So I want to complete this introduction to your machine learning in a faster way, and let's go in the concept of your medical oriented in a slower way. Okay, what we cannot do. Okay, what we cannot do. Okay, so what we cannot do in this particular area means the social contact. Okay, the context what we'll be having of. Okay, so the awareness. So if you are doing of, we should have the ethical. What to say? The rights. Okay, without the particular ethical considerations, if you are doing anything, okay, it will be into your problem. Okay, so the next thing, we cannot solve the problems in the case of your ambiguity and what is your variability. So what's mean by this particular ambiguity and what is mean by this particular variability? So a particular word that will be having your the same meaning. Okay, so when you work with the particular firewall, this is the biggest problem what we have. Okay, the ambiguity and the variability. Okay, so now slowly we are going to move for the particular disease predictions. Okay, so how we are going to predict the particular diseases, okay, and the fit of the machine learning. So here, what we'll be doing of means, first we should select for what we are going to work on. Okay, so here's a small example. We have taken it as your early diagnosis. Okay, so if you want to say the particular terminology as an early diagnosis, we should know what symptoms. Okay, based upon the particular symptoms only, we'll be uh, working off, or it will be helping us to identify whether this particular disease is present for people or not. For that, we require a particular data set. Sorry, the data set. So here, this particular machine learning models, it will be using the historical data. What is meant by historical data in the sense, the previous data, what you're already collected. So please note this when you're working with your, what to say, oriented data, ethical constraints is a must. So what is the particular ethical constraint? Ethical constraint is nothing but you have to get the consent from the patient. Okay, the human being will be saying of human being is nothing but the person. If he or she has been affected, we'll be saying it as your patient. So from this particular patient, we'll be getting so we have to get the concern. Okay, so that is a foremost thing. So here historical assessment, we'll be collecting slowly little bit data and we'll be storing and we'll be keeping off. So nowadays, if you store and keep the particular data, data should be preserved and kept. Okay, so we have to have the logic of your data privacy also, this particular area. And here the authentication plays your major role. Okay. So what are the sources, of the particular data, for the particular prediction? What is meant by the data sources means we'll be saying it as your electronic health records. Okay, electronic health records is nothing but the health record which has been converted into what means electronic format. Okay, for example, I hope in the older days the X-ray has been taken and it has been given for you people in your hand in your black color X-ray sheet. Okay, so nowadays, this particular X-ray sheet has to be stored and kept electronically. How to do it means, so it has been digitalized. Okay, it has been made as the format of your computerized. The next thing, let us go in the case of your ECG. Okay, so the ECG has been printed and it has been given in your hands. Okay, so this particular thing has to be digitalized and it has been stored. It has to be stored. Okay, so let me go with this comparison of this only particular two data. So one, let me say as the X-ray, the one more is a ECG. I'm taking this particular thing as an example. Means, very frequently we'll be taking these two things. Okay, so now in this particular two parameters, what are the data that I can take and keep it off? Okay, first and foremost thing, for what purpose this particular X-ray or this particular ECG has been taken. Okay, so let me take detail about what means your X-ray. For example, in the case of the hand fracture. Okay, so in the case of hand fracture, what are the things that we have to notice? The first thing it is your who's the patient name. What's the age of the patient? The patient is a male or female. The next, what is the if you want, it's a phone number of the particular patient. Okay, so like this, we'll be collecting few information, and this particular data will be stored in the particular next column. So we'll be saying, let's say, what means a particular user, okay, a row and column format will be saying of. Okay, so in a particular row, this particular things will be present. So we'll be going the next thing in the concept of your what means ACM matrix will be going off. What is mean by this particular ACM matrix? Just like I said about your what means data privacy. Okay, ACM is nothing but access control matrix. So for each and every column, for whom all we can give the rights. Okay, so that should be here in the next parameter that what we'll be seeing of. So these are the challenges what we'll be having. Okay, so the next thing in the case of your medical imaging. So this itself, okay, this particular X-ray itself, it can be stored and it can be kept in the format of your image format. Okay, so like this will be going off. The next is how we are going in the case of your geometric data as variable devices. Okay, for example, for me, if I am somewhat dumb and deaf, okay, what type of data that I am using in that particular device, what type of sensors I'm going to use. Okay, so all those. Okay, so these are the data sources, how we'll be collecting and we'll be keeping it off. Okay, so next, for this particular what to say means disease oriented, how we are using this particular machine learning technique. Okay, we have seen, as we have seen earlier. Okay, we have seen what is meant by supervised learning and supervised learning. Still, we have said it as your reinforcement. Still, the depth of your reinforcement, we will be saying it as your what means your deep learning models. Okay, so the next thing we want the algorithm. Okay, algorithm is nothing but I can say if I want in a simple step, it is a step-by-step rule. Okay, how it is going to behave or how it is going to work. Okay. So in the case of your supervised learning, so let me go in the case of, okay, what is mean by your decision tree? In a simple way, let me go it off. Okay. So I hope how we'll be taking your decision. Okay. So let me go with a simple if condition. If the condition is true, the first statement will be executed. Else, it will be moving for your what means the second false statement. So like this. Okay. So what happens if here we have more number of decisions? Okay, level by level. We used to say this as your what means a decision tree. Grouping of n number of decision trees will be saying as your what means your random forest. So these are the simplest mechanisms or simplest models what we'll be having of. So when we go with this particular supervised training models, okay, or supervised learning models, what will be the advantage for us? Okay, what will be the advantage? What will be the advantage for us? Okay, you can raise this particular question. So the output prediction time, okay, output prediction time will be what the same is very less when compared to your other models what we have in this particular area. So what is the challenge or the threat that we'll be having of means it the challenge or the threat we'll be saying in this particular area it is it one area the time we say it is a very simple for calculating or what to say saying the correct one. The other area we say it takes more amount of time. So see here the time itself plays here contrast in the two particular things. Okay, the next thing it is unsupervised learning. Here we'll be going in the case of a clustering. So when you do in the case of clustering, here n number of clusters will be made. So here what we'll be doing often we'll be dividing to small parts. Okay, so we'll be saying this as your segmentation. Next we'll be going in the case of the deep learning models. Okay, so this particular deep learning models it is for the dynamic data sets. We'll be updating the particular data sets then and there. Okay, so we'll be working with the particular time series health data by using this particular deep learning models. Next, for improving all those things, we are going in the case of your ensembling methods, bagging models. Now we'll be saying this transform models. So like this, we are having n number of different models for improving your accuracy and going ahead. Okay, what are the different types of diseases we can take it off? Okay, we can take it as a what means the cancer detection. Okay, so for this particular cancer, we'll be taking the case of your images or the pathology reports what we get. The next cardiovascular diseases. Okay, the risk assessments, diabetics. Okay, what we have the neuro oriented forecasting. Okay, and the other diseases what will be having of. So if record this particular thing, we can go and work with the afterwards. Okay, so here there is your small project. Okay, so we'll be working with this particular project if required. The next thing. Okay, let me go for a how we are going to detect the particular Parkinson's disease. Okay, so first and foremost, we should know what is meant by Parkinson's disease. Whether you have the idea regarding this, what is meant by Parkinson's disease? Okay, fine. So this Parkinson's, if I want to say in one word, okay, it is not a small disorder. I'll be saying. Okay, so this particular thing, it is your age. Yes, please. Okay, I'll be a little louder. Is the voice is audible to all or any issues? Do you have any issues here? Okay, fine. Thank you. Thank you. Okay. So here, let me go step by step. Parkinson's, it is a brain oriented. So we have some disorder in the particular brain oriented based upon the age factor we'll be saying of. Okay. So what are the symptoms that we have in the case of this particular Parkinson's? Okay. So if I want to say in a one word, like shivering, okay, shivering or shaking, okay, your hands will be shaking continuously, your jaws of your mouth will be shaking, your legs when you sit, it will be shaking. Okay, then what happens is you'll be rubbing your hands or you'll be catching your hands tightly, okay, and you'll be rolling. Okay, you'll be rolling your hands. You'll be doing. Okay, so these are the smaller symptoms what we'll be finding in the case of this particular Parkinson's. Okay, so this particular thing we used to say it as a tremor. Okay, tremor will be saying of. The next thing it is we'll be using or we'll be going with the concept of your slow movements. Okay, if it is very slow movements, it is somewhat more difficult for identifying and it will be going off. So in the case of your Wattmans, the chair, when you're sitting in your particular chair, all of a sudden you cannot get up. Okay. So this will be your problem, what you'll be having of. But we'll be blinking very easily. Okay. In the case of this particular thing, even you cannot move your or close your eyes in a faster way. So the movement of everything will be reduced and it will be going off. So this is also your one type of a problem what we'll be having of. The next, what is meant by rigid muscles? Okay, rigid muscles is nothing but tight. Okay, your muscles will be very tight. Okay, if I want to say it's now if you're pressing your hand and your body, okay, it'll be somewhat little softer. So it'll be like a stone. Okay, it'll be more harder. Okay, it'll be very tough. So like that, it'll be going off. And you'll be always feeling like what means hands and legs. Okay, the parts, some parts of your body when you're moving. When you're moving, it'll be somewhat harder or it'll be somewhat painful. So like that, it'll be going off. So like this. And you'll be the next thing is a poor posture and balance. Okay, you cannot get the balance. So what you'll be doing often is you'll be catching the wall and you'll be walking or you'll be using like your sticks. So like that, you'll be having off. The next will be having like what means the changes in the particular speech. Okay, you cannot speak continuously. Okay, so what happens is your speech will be somewhat flat or monotone. Okay, or sometimes what will be happening of means pattern in the particular speech will be changing off. So this will be also one type of problem what will be having off. So next, I hope we used to have the fast writing mechanisms. Okay, in taking the pen and we'll be writing. So the catching style of the pen itself will be changing off. For example, if your hand finger has been getting hurt, then you cannot catch in the normal position. So like that, it will be going off. So this will be your next these are the small symptoms what we have. Okay, the tremor, it is the biggest thing. Okay, like shivering. Okay, everything will be shaking in your body. Okay, fine. Let us go in this particular what means Parkinson disease, how we are going to detect. Okay, so what we are going to do here means we are going to create one particular GAN model. Okay, we are going to create one particular GAN model by using your CNN. Okay, what is this particular GAN? Okay, if I'll simplify this particular GAN, so it is one particular network, okay, which is used to make more number of samples. I'll be saying. Okay, so this particular thing I can abbreviate it as what means a generative adversarial network. Okay, so for what purpose we are using this particular generative adversarial networks means. So here, this particular thing, it will be working with the two neural networks. Okay, so one we said here is the case of what means your CNN. Then what can be your next network? We can raise the equation. So GAN itself it will be acting as a one particular model in this particular area. Okay, so this particular thing will be connected like your what means your neurons. Okay, so this particular thing, it will be used for classifying the particular Parkinson's diseases according to the particular stages. Okay, so here we are going to use your MRI image data set. Okay, so the next thing what we'll be doing of means by using the particular GAN, we have here what means get synthetic images. Okay, so why we are going for the particular synthetic images? Okay, Can anyone say why we'll be moving for the particular synthetic images? At least what is meant by the synthetic image? Please, can anyone? In the, what to say, human oriented diseases, why we move the particular synthetic data means we'll not get more number of samples. Okay, we'll not get more number of samples. So what we'll be doing of means by keeping the existing images, we'll be trying to create like your what means we'll be by using the particular GAN model, we'll be creating more number of synthetic images, like your what means duplicate images or a copy of the particular images. Okay, for what means for doing your data augmentation, addressing the limitations what we have in your data set. The limitation is I cannot go and get n profile, okay, the particular data since it is a confidential, some diseases are. So like this, it will be going on. The next thing what we'll be doing of means here in the machine learning models will be two things plays a major role. One will be saying as a training and more will be saying as your testing. So here we are going to use the particular CNN classifier for what means we will be using your real and the synthetic data. So see here, two data as came here. One, it is a real data and more is your the duplicate data or the copy of the data what we are taken and we have kept. Okay, to improve your diagnostic accuracy. Next, what we'll be doing of means we'll be extending the particular methodology for diagnosing the other neuro diseases. Okay, like Alzheimer's. Even Alzheimer also, I have worked the same GAN model. If required, I'll give the particular thing. Okay. So, what has made us to work on this particular project? Yes. Yes, please. Okay, fine. Okay, what has made us motivated here to work on this particular thing? To find earlier. Okay, to find earlier from the particular MRI images. Okay, we'll be taking off. So if you're going back here and if you're seeing off, okay, so here we have the lots of symptoms. So where this particular, all this particular symptoms, tremor, okay, the shaking, slow movement, okay, rigid, okay, the what is it, the balance factors, the next is your automatic movements, the changes of your speech, okay, where this particular thing will be affecting means slowly it starts affects your brain condition, okay, it will be affecting your brain condition. So all these particular factors, it depends upon your awareness to your brain. How we'll be doing augment. So we are going to take our brain only the MRI. Okay, so by this I'm concluding our images will be as your brain MRI only. So by taking this particular MRI images, we are going to diagnose it. Okay, first we are going to identify the particular thing. And this Parkinson, which particular category it is going off, that we'll be identifying and will be suggesting for the treatment strategies. Okay, so the data set what we have received, okay, or what we have, it was very small. Okay, so only it was only 300 images what we had. Okay, so and there was a one particular problem. It was imbalanced. Okay, so how to make a smaller data set into your bigger data set? Why means we have to train with n number of more images. Okay, then only when you are testing, our accuracy level will be somewhat higher. Okay, if you train with your less number of data, then what happens is, the accuracy will not be as perfect. Okay, so this is somewhat limiting our performance. The next thing we'll be going. Just a minute. sorry. So here, what it will be happening in the case of the diagnosis method means we are nowadays we are depending on the particular manual process. Okay, so for this particular results, what we receive from the external agencies or while doing this particular manual process, it is taking a too much amount of time. Okay, so this is a first problem. Okay, it is your time consuming process. The second thing it is here in some cases uh, a possibility of what means small errors. Okay, what we'll be saying of means okay, the small errors it will be proning. Okay, so this particular thing we'll be saying like your what means the fractional errors will be saying this. Okay, so this will be proning to your errors. The next the synthetic data what we are generating. Okay, what happens with the particular GAN? It will be addressing the lack of high quality in the case of your training data sets. Why means you are making it as a copy. Okay, as it is, we'll be getting off. Okay, as it is, we'll be getting off. So what happens here means uh, we cannot find more changes in this particular thing. So what we are planning to suggest it is we are planning to use the particular AI powered tools, okay, to improve the particular accessibility, scalability, and the resource constraints. Okay, resource constraints in the sense of making the manual process into your automatic. Okay, so the time will be reduced. Okay, I hope I know you to repeat this again. Okay, let us go. Okay, so how this particular methodology is working off. So first, let me take the particular input and speak of. One part is your what means a input data. Input data is nothing but your brain images, what we are taking and keeping off. The other area, it is your what means we are saying it is your GAN. Okay, GAN images. Okay, it is your synthetic images, what it has been generated, and it is a person. So the case of your generator, we are having two things. One will be saying it as a what means generator and the discriminator. Here, the images what you are taken as a real will be doing the particular data pre-processing. Why we are doing here the particular data pre-processing? That is a question what it has to be raised to remove out all your outlinears. What is the outlinears in this particular area? So the unwanted noise or the unwanted particular data what we have. Okay, when you do in the case of your resizing and all those things in this particular area. So after that, what we'll be doing of means we'll be creating the particular real image. What will be acting as your input for your methodology or the project. What we are going to do it of. The next thing. Okay, so we are going to combine your real data and the synthetic data. Okay, so this we'll be saying as your data augmentation. Okay, so what is mean by why we are mixing this particular thing? Why we are doing this particular thing means it should not be what to say means find it in your easier way. Okay, the first data what we send as your is your real data. The next is your what means the generated data. Okay, so like this it should not be that. So it should be since we'll be working with the what means like your unsupervised methods. All the data what we have it should be in your mixed manner. Okay, so next we'll be passing this to your CNN classifier. So in this particular CNN classifier, we'll be having your convolutional layers. Okay, and pooling works will be done in this particular area. So this will be passed for your fully connected layers. Okay, the output of what it will be doing means it will be classifying and it will be giving how much percentage. Okay, the particular thing has been affected. Okay, it's an early stage or middle stage or it is your fully affected state. So like this, it will be classified based on the particular what is same means the stages. Okay, so that is the output what we have in this particular area. Okay. So the whole idea of this particular work it is to identify, the particular Parkinson diseases in your early stage by keeping the limited data sets, low amount of data, only 300 images we had. So by keeping this, we have created more number of images and we are working off. Okay. So we said here it as your what means a dual stream. Okay. What is mean by here? It is your dual stream. Okay. Dual says the two streams we are going to use it of. The two streams is nothing but for the data set, we say it as your one, it is your real data, one more, it is your synthetic data. So here we are using two different networks. One network is for what means generating your synthetic images. One network is for doing your classification based upon the particular futures. So, what is the input of the particular model that we are going to work it off? Means we are going to use your MRI images. Okay, so the category is the T1W and MRI, and output it is your classified labels. Okay, whether the particular image what you have passed it is healthy image or else it is your what means affected by the Parkinson disease. Parkinson disease you are labeled as your PD. Okay. So how we are working in this particular thing means I have written this as a small what means as a pseudocode model. So we'll be doing two works. One will be saying it as a what means your training phase. One more will be saying it as your testing phase. So the training phase, what we are going to do of. First, we are going to generate your synthetic image from what means the sample that we have taken already. Okay, in this we are going to mix little amount of noise. So that what happens is we'll be getting somewhat what means a modified image. Okay, so this is a particular thing what we'll be doing in this particular area. Next, we'll be computing the discrimination, the losses. Okay, between your real and the fake. So which particular thing the particular loss is more. Okay, will be calculating and will be upgrading the particular weights for the particular discriminator. So this particular thing we'll be saying is your what means a training discriminator. Next, in the case of your training generator, what we'll be doing of means we'll be generating the particular images and we'll be passing to the particular discriminator. The next thing we'll be going and computing the particular generated loss. Okay? Generated loss based upon the output what you received from the discriminator. Okay, so this is the next one. And we'll be upgrading the particular weights. So we'll be having your updated discriminator weight and updated the generator weight. Next, what we'll be doing of means we'll be going to your CNN classifier and we are going to take the particular data set of your input, okay, with the real and the synthetic images. Next, we are going to apply into the particular convolution layers for the particular futures extraction. Okay, so we'll be having a number of futures based upon the particular futures. Okay, it has to classify and it will be giving for us. Next, we'll be flattening the particular future maps and we'll be applying the particular connected particular layers. So based upon this, we'll be computing your loss and the entropy. Okay, so this is a working model how we'll be having in this particular area. Okay, so what is the data set that we have taken? So this particular data set we have taken as a tau. Okay, tau, a Parkinson's data set. So in this, from where it has been taken. So this is available in your open source. So we have taken here. Okay, even though we have taken, we have submitted the particular agreement form. Okay, so this has been created by National Institute for Research and Development in the Informatics. So here we had only 161 data. Okay, so out of this particular 161 data, there was only 40 subjects that has been present. How the particular data composition was present means it has been taken from a 20 patients with the particular Parkinson disease and 20 particular normal images. Okay, so 20 plus 20, it is 40. And by keeping this particular 40, we have created 300 images. Okay, so this particular thing has been created in your synthetic way. Okay, so this was a method how we have collected the particular data. Okay, so what was the first step in this particular thing means we have resized the particular images. Okay, 64 in 64 pixels. Okay, and we have kept the particular normal, and we have worked with the particular normalization and with the standard deviation, and we have fixed the particular threshold as 0.5 and 0.5 for the both the things. And what we did means we have started to convert the particular pixel from the range, okay, 0 to 1. Okay, so this is the normal, and for us, by keeping this, we have started our stable training. So when you do your particular data augmentation, we'll be doing all the activities like rotating the particular images, flipping the particular images. Okay, so this particular flip images horizontally, for this a probability what we'll be having it is your 50%. And the case of rotation, we'll be rotating it with your 15 to 20 degrees plus or minus. So this particular project has been worked with the concept of your so the Python by using the particular PyTorch tensors, okay, for converting all those things. Okay, and here we have for the normalization and for the rotation formulas. Okay, so out of 300 images, what we are divided here into two parts. One part we are taken here it is for testing, and one part we are taken it for your training. So we are taken as a 80-20. Okay, 80% for your training and 20% for the testing. So 240 samples has been taken for what means a training purpose, and 60 has been taken for what means for the testing purpose. And the futures what we had here in this particular area is the text futures, the edges, grayscale, intensity, how it is varying from one to another. The next image coherence, next the edge patterns, shape consistency, the noises. Okay, so the lines, edges, okay, and all those things we have taken as a particular future of the parameter. Okay, so how the particular model has been trained. Okay, so we have taken the first part as your GAN network. So in this particular GAN network, okay, so in the particular GAN network, what we'll be doing is we'll be trying to produce more number of images. Okay, this particular images should look like your real-time images. Okay, so the discriminator, what it will be doing of means it will be distinguishing between your real and the particular fake images. So this process will be saying as your what means a game adversarial game, because what means this particular both the things are trying to act like you're smart. Okay, so this is your step one. Okay, step one should be how much number of images you want, you can create and you can keep it off. Okay, so the next thing what we'll be doing of means the next we'll be trying to mix all those things, and you'll be trying to put this into your CNN classifier. Okay, and then you'll be using the particular cross entropy, and we'll be evaluating your what means accuracy, precision, and recall. Okay, so let me speed up. Okay. Okay, so here what happens is we'll be having your dual stream. Okay, so in this particular dual stream, what happens is one we are saying it as a what means generator and discriminator. So the next part after doing this particular thing, we are sending into your classifier. After this, we are doing the particular process. How many number of layers that is present? Okay, the generator we have 4 layers, the discriminator we have 3 layers. Okay, all fully connected. So in the CNN classifier we have 4 layers. Okay, so these are all the number of layers what we have. Okay, so after doing all those things, this is a particular confusion matrix what we have received. So based upon this, we have calculated this particular accuracy. Okay, so these are the things in the case of your Parkinson disease, how we are going to predict and how we are going to say it off. Okay, so the formulas, I hope you will be very clear. Okay, for the accuracy, we'll be going with the true positive plus the true negative divided by all the factors, true positive plus true negative plus false positive plus false negative. So like this, we'll be going off. The next thing will be going in the concept of your precision. Only will be considering your true positive divided by true positive plus false positive, and we'll be going with your concept of your recall values. So true positive divided by true positive plus false negative. So like this, you'll be calculating your results. Okay, so here the accuracy plays your major role. Okay, so let me go here. We have tried this with your different algorithms. So out of this particular different algorithms, this particular dual stream model has given the highest accuracy. Okay, so the highest accuracy has been shown in the case of a blue in color. So 99% it is. The other models has been given less than that. So this particular zebra model was a challenging task for us. But whereas in the case of this particular thing, zebra model. The other factors was somewhat less. For example, if you're going in the case of a precision, it is less. Okay. Okay, fine. So let us go for the still the extension of this particular thing, where we are going to use this particular all the activities. Okay. So again, going back to the introduction slide. So in the introduction, what happened it is. So in the case of your introduction, sorry. So if you are going to this particular our title, so one part is your machine learning. We have seen a few things, introduction about your machine learning. The next we said it as your disease prediction. I hope you have seen about your what means the Parkinson disease, how we are going to predict the particular thing. Okay. Next, let us go. What are the risks that we have? Okay. What are the risks that we have? The first risk I have said it as your the data collection itself. We have the risk. The next risk will be having how to preserve and keep the particular data. So this is a next particular risk what we have. Is the slide is visible? Can anyone please respond? Whether the slide is visible?
Yes, sir.
Okay, thank you, thank you. Okay, let's go for the last part. Okay, so how to what to say? Predict your risk. Okay, where all the particular places your risk will be present. Okay, so these are all the factors that will be seeing analysts. Okay, so here the risk will be predicted in the hospitals. Okay, how if you're asking once, we'll be saying how to store and keep your data in a confidential way. So this is the first parameter what we'll be having of. The second thing it is how you'll be identifying the particular patients. Okay, prevention care. Okay, there should not be any leakage of the particular information. So this should be your second thing. The third thing it is how you'll be estimating the particular surgery compliances. Okay, the probability. And what is your disease risk strategy, chronic risk strategy. So these are the things. So let me go. So if you are going in the case of your risk, what we'll be having of, okay, the data privacy and the security concerns. Okay, here the electronic health record, as I said in the earlier, so it will be having your what means your personal information, okay, your financial data. Next, what are the problems that you are facing, or what are the how it has been occurred and kept. All those things will be saying as a what means the health record will be saying how this particular health record has been collected from you people and how it has been stored and kept. So this is first particular problem in the case of the data sensitivity. The second thing will be going in the case of your information identification of a particular person. Okay, so it is your name, it is your address, okay, the insurance, okay, the next the genetic information, okay, all those things. Okay, so who will be taking this particular information or all those things? We used to say it as your what means the in the as a terminology named as a data theft. Why the particular data theft is occurring? To make money. In a simple words, we'll be saying off. Okay, so they'll be saying we are collecting for a research purpose, and it may be used in a wronger way. Okay, so that will be going off. So here we'll be having your what means the confidentiality of your data. When this particular confidentiality will be going off means we'll be believing and we'll be giving our data in the hospital or with the third parties. So when this particular data, okay, the trust what we have on the particular hospital or the third party whom we give, if it has been misused, okay, then it is known as a violation of the particular rule. So like that, it will be going on. The next, the cyber security threats. Okay, so for how much, for example, they'll be stealing some other hospital's data. Okay, I can define this particular ransomware attack in a different way. I'll be saying it as a ransomware. Okay, ransomware and hide. Why means the hacker will be coming and he'll be disturbing you. Okay, why he'll be continuously disturbing you? That is the question. That is the question what we can raise here. Okay, so see here they'll be what to say, attacking your server in your hospital, or they'll be sending some unwanted messages, okay, or they'll be filling your particular memory. So like this, the problems will be created and it will be going off. So what happens is they'll be demanding some money from you people. Okay, so when they demand some money, then what happens is you have to pay. Okay, they'll be continuously asking again and again. So I said as your ransomware and hide attack. Okay, so they'll be encrypting and keeping the particular hospital's data. So like this, it'll be going on. Next, let me go on the case of your the malware. Okay, so sending the what to say means the malicious code. Okay, malicious code through some particular what to say means connections, and attacking the entire network. Okay, okay. So like that, they'll be doing off. So it is one of your particular vulnerability. The next thing it is, we'll be going with the IoT devices. Okay, I hope everywhere we used to go and connect the Wi-Fi. Okay, so in the particular Wi-Fi itself, as itself, they'll be collecting a number of information. Okay, so when you're using your IoT devices, you should be very clear. So pacemakers and all those things, it will be a small examples in this particular area. The next it is the exchanging of the information between your two particular organizations or the two parties. Okay, that's your risk what will be having of. The third party vendors. Okay, for example, I'll be running or owning an hospital. I'll not be having the lab in my particular hospital. So what I'll be doing of means I'll be referring you people to go and visit the particular what to say, the lab or the particular center. So there, what they'll be doing of means they'll be taking our data and they may give for the other hospitals or the other particular areas. So these are the problems what we'll be having here. Okay. So next, in the training of data, we'll be having your unpredicted or unfair. Sorry, I cannot say this unpredicted. Unfair decisions. Okay, unfair predictions. So how this will be occurring means, okay, it will not be related. It will be not be related, or it will not be representing the real world, okay, population or the particular task. Okay, some what to say means unbiased decisions it will be giving off. So when you go on the case of your data sources, in the case of your BIOS, it is classified into different categories. Okay, one will be saying as your sampling of your data. The next will be saying it as your what means labeling of the particular data, the historical data, the exclusive data, and all those things will be having the different types of biases in the particular data. So here BIOS itself will be saying that it is somewhat what the same as allowing us in a liberal way. Okay, we say in our terminology, bias, you are getting biased. Biased means you're not following the particular rule. Okay, so like that, it'll be going off. So this particular unbiased training, it'll be leading to your unfair predictions. Okay, so if you have any queries in this particular presentation, okay, in the three different parts of the presentation, you can raise all your queries here. If there is a query, you can raise, please. Okay, I hope there is one particular question in the chat box. How will you handle the particular overfitting problem? Okay, so here the overfitting problem can be handled by different strategies. One, by increasing your training data. Okay, so what it will be doing means here we'll be trying to represent your training data that will be helping in a generalized pattern rather than memorizing your specific examples. Okay, so like that we can do it. Next, if you are going in the case of your data augmentation, so we are working here in the case of your images. So what happens here means we'll be creating the different modified version of the particular existing samples. Okay, so how much we'll be trying to rotate the particular images. We'll be trying to flip the particular images. I hope we are given the rotation degree and flipping degrees and all those things. And you'll be adding your what means the noises. So like this, we'll be doing off. In the worst case, we'll be going in the case of what means the dropout. Okay, randomly we'll be trying to drop out the deactivate neurons. Okay, or the functions what we'll be having off, and we'll be learning to go to the more robustic way. And if you want in the case of still means we can go for your cross validation. Okay, that is also one thing we'll be having here. And still, if you want to fine tune and take it to go off means we can go with the concept of your enzyme link models. Still any queries? The questions are most welcome. Due to scarcity of time, I hope I have skipped a few things. Okay, there is a question in the chat box. What are the different types of enzyme link models that we have? So we can go with the concept of your future bagging. So that is the one particular methodology what we'll be having of. Next, the boosting algorithm, like a gradient boosting algorithms. So like this we'll be having of. So what it'll be doing means it'll be reducing the particular variances. Okay, and it will be trying to improve your generalization. So this is the work. Okay, the advantage will be saying off in the case of this particular enzyme models. So this particular enzyme model also is somewhat like your addiction tree only. Any other questions or any other queries? Okay, thank you. There is a question again in the chat box. What are the recent algorithms that we'll be using for the medical image analysis? Is it right? The question is right? So I hope your neural network models, okay, itself plays your major role. So beyond that, if you want to go, I can suggest.
The question क्या तो zero. Bar in Celsius thermometer is the melting point of that.
I can suggest few segmentation algorithms.
Degree Celsius
Okay, segmentation algorithm or a deep learning. Very simple, if you want to, I can go with the deep learning based segmentation. So this is a one particular thing. So in specific, if you want to go the edge detections algorithms, you can go. Okay, I hope it is a canny. I hope. Okay, I'm not clear on that. Canny, that particular algorithm, you can go off. If you want in the case of extracting the particular features from the particular images. In the case of the particular cancer oriented and other things, you can go with simple with CNN, SVM, by keeping this particular GAN. So CNN, we have worked for two particular small projects. One, it was Alzheimer, the one more, it was Parkinson's. Thank you. I hand over the session to the organizers. Thank you for giving this particular wonderful opportunity. Thank you. Thank you to all.
Thank you so much, sir. That was a wonderful and insightful presentation. We once again request all participants to fill out the feedback form for this session as well. Your feedback is highly valuable to us and will help us organize even better programs in the future.
Thank you.
On behalf of the Department of Artificial Intelligence and Data Science, Mahendra College of Engineering, I extend my heartfelt gratitude to Dr. M. Alagiri, sir, for gracing us with your presence and delivering such an impactful session today. Sir, your lecture was truly enlightening and full of rich insights. The way you connected theoretical knowledge with real-time scenarios was truly commendable. Your guidance has helped us understand how AI technologies are not just concepts, but real solutions shaping the future of healthcare. We sincerely appreciate the time and the effort you have dedicated to being with us and sharing your expertise. Your session was undoubtedly left us inspired and motivated to learn more and apply this knowledge in our professional journey. Thank you once again, sir, for your gracious presence and valuable concentration. I repeat, we once again request all participants to fill out the feedback form for this session as well. Your feedback is highly valuable to us and will help us organize even better programs in the future. Before we conclude, I would like to take this opportunity to express our deep gratitude to AICTE and Atal Academy for sponsoring and supporting this faculty development program on cultivating innovation AI in healthcare. Their constant encouragement and vision make us initiative possibles, creating platforms for faculty and institutions across the country to learn, share, and grow together. We also extend our thanks to our management, respected principal, organizing team, and all our resource persons for their unwavering support and efforts in making this program successful. A special note of appreciation to all our participants whose active involvement has made these sessions lively and interactive. Finally, before we wrap up for the next day, we kindly request everyone to complete the feedback form and being shared in the chat. Your suggestions will help us improve and organize even more impactful programs in the future. Once again, thank you to everyone who contributed to the success of Day 4. Let us continue this learning journey with the same energy and enthusiasm for the remaining sessions. Thank you all. Have a great night.